We're going to do number 12, the second part from Chapter 2. We're assuming that we have four natural numbers, m1, m2, n1, and n2. We're also assuming that m1 is strictly less than m2, and that n1 is strictly less than n2. And then our goal is to show that the product m1, n1 is less than m2, n2. We do have a theorem that might help us with this. This theorem is similar to what we're trying to prove. We're assuming that we have three natural numbers where z is not 0. We're assuming x is less than y, and we're concluding that x times z is less than y times z. But in our case, we have four numbers with strict inequalities between them. And we observe that in Theorem 17, only one thing changes, namely x times z is less than y times z. It's the same number, but we're assuming that z is not equal to 0. So in order to use that theorem, what we can do is we can try changing one thing at a time and seeing what inequalities we get. But one of the assumptions in Theorem 17 was that z was greater than 0, and the hint suggests, well, let's try first showing that m2 is greater than 0 and see whether that helps us to apply that theorem. So the assumptions that we have are that m1 is less than m2, but we also know from Theorem 10 that 0 is less than or equal to any natural number, including m1. When we put those together, we have 0 is less than or equal to m1, which is less than m2. And so by mixed transitivity, that is Theorem 2, we do indeed have that m2 is strictly greater than 0. Now, just in case we need it, we can observe that the same argument would apply to n2, so n2 is strictly greater than 0. So here are the inequalities that we have to work with. Namely, m1 is less than m2, but that m2 is positive, n1 is less than n2, and also n2 is positive. Now, the first thing we do is we use Theorem 15, which was similar to Theorem 17, except that it was a non-strict inequality and you didn't have to make any assumptions. So since m1 is less than or equal to m2, we can multiply both sides by the same number, n1, and get that m1 n1 is less than or equal to m2 times n1. The next thing is I would like to replace the n1 with an n2. So the first thing that we do is we use the fact that multiplication is commutative to put the n1 in the first position. That's because in both Theorem 15 and Theorem 17, the thing that changed was in the first position, and the thing that stayed the same was in the second position. So we want to change the n1, so we just switch the n1 and m2 so that n1 is in the first position. Now, the next step is Theorem 17 allows us to say that since n1 is less than n2, n1 times m2 is less than n2 times m2. So here is where we needed to use the fact that m2 was greater than 0. Now finally, for the last step, we use the commutative property so that our product is in the right order. So we have m2 times n2. Finally, putting all of this together, we have that m1n1 is less than m2n2 using mixed transitivity, in other words, theorem 2.